right, hopefully you have this note sheet in front of you for lesson 5-6. Today we will be talking about tangents, secants, and their angle measures. So just a few more theorems to learn today. So you may recall from last week, a secant is a line that intersects a circle in exactly 2 points. Remember, we have this on a note sheet, but we'll draw this again. This is an example of a secant line. And remember, a secant contains a chord, right? The chord is just the segment. The secant is just the line that goes through that chord. All right, and also last week we looked at a tangent line. Remember, a tangent line intersects a circle at exactly 1 point. So knowing that difference, we're going to be looking at both of those lines together today. So one theorem we learned was the inscribed angles theorem, that an angle, if it's inscribed, you're used to this picture. We've got two secants intersecting to form this angle 1. And remember, its measure is going to be 1/2 its intercepted arc. Now, notice this one is formed by two secants. You can also have an inscribed angle where the vertex lies on the circle if you have a secant and a tangent. It follows the same rule. So the intercepted arc is a little bit easier to see on this first picture right here. So let's say measure of angle 1 is 60. We know that x would be 120 degrees. You just double that. Same thing on the second picture. If this measure of angle 1 is 60, x is still that intercepted arc, just looks a little different. It will have a measure of 120, just doubling that measure. Okay, and that's what this formula here is stating. All right, these two pictures down here now are two new theorems. We will have two secants in this center picture intersecting inside the circle. Now notice their intersection point does not necessarily need to be the center of the circle. Okay, that's really important. So you don't want to assume that the measure of angle 1 is equal to y. That's only if they're intersecting at the center. So if we have this intersection point that is off-center, the only way to find this measure is to take the average of its intercepted arcs. And this is what the theorem is stating over here. Measure of angle 1 can be found by taking x plus y and multiplying by 1/2. It's 1/2 the measure of the sum of the intercepted arcs. So x and y are the intercepted arcs. Okay. So if this is, say, 40 and this guy's 50, then we would find the measure of angle 1 by taking 1/2 of 40 plus 50, which would be 45 degrees. Okay. All right, and the last theorem, if we have an angle formed outside of the circle. Now this can occur if we have two secants. Notice this angle out here. We can have a secant intersecting a tangent. This is angle 1 here, or two tangents. They all form this outside angle. So it's kind of very similar for the formula here. Notice if an angle intersects inside the circle, we're going to add the two intercepted arcs and take 1/2 of that. If it intersects outside the circle, we subtract the intersected arcs and multiply by 1/2. So it's 1/2 the measure of the difference of the intercepted arcs. Okay. So when you look at this picture, for instance, this first one, x is the bigger intercepted arc. This y, let me use a different color, is the other intercepted arc. So if x was maybe 100 and y is 20, the measure of angle 1 would be found by taking 100 minus 20, and I wrote too large, multiplying by 1/2. So you would have 1/2 of 80, so it would have a measure of 40 degrees. Okay. Notice how the intercepted arcs in these other two pictures, if you have the second picture, we have the secant and the tangent. X is this arc, y would be this arc. So you would subtract those two arcs, multiply by 1/2. And the last picture, the two tangents intersecting to create that angle outside the circle. We have the first arc is x, the second arc is y. Now notice in this case, x and y form the whole circle, so therefore add up to 360. So hopefully you see that. All right, so just a few examples, guys. If I find the measure of angle 2 here, notice we are finding an angle on the inside of the circle, so we want to look at the intercepted arcs. Essentially, we're not finding that angle directly. We want to find this one, which is, of course, the same as its vertical angle here. So we want to add the two intercepted arcs, divide them by 2. Just show your work, please. So x will be 1/2 times 48 plus 38. And I already plugged this into my calculator earlier. I think I got 43 degrees. So x would be 43 degrees, which means measure of angle 2, you would just subtract that 43 degrees from 180 and get 137. Okay. All right, example 2, we're finding measure of angle 4. A few different ways to do this. Again, I see I have a secant intersecting a tangent. This vertex is on the circle, so it is an inscribed angle. It's going to follow that same rule as an inscribed angle. So this is the intercepted arc, which I can find by taking 360 minus 124, which gives me 236. And the measure of angle 4 will just be found by taking 1/2 that measure, which is 118. All right, in our last example, example 3, we have solved for x, and again, we see this is a tangent line and a secant line intersecting outside the circle. This angle will be formed or found by taking the difference, 1/2 the difference of the intercepted arcs. I don't know this arc in pink, but I can find it, and I do know 60. So notice if we have 144 and 60, I can find the remainder by subtracting them from 360. So this pink arc will be 156. Therefore, x can be found by taking 1/2 of 156 minus 60. And I got 48 degrees. Okay. So those are 3 very basic examples. I do have more examples on the back. Feel free to look at them on the video that I will be posting as well. But just kind of quickly to look at how similar these all look, and just slowing down and seeing, which theorem you will be applying on each. So we've got the two secants intersecting on the outside, right? So on this one, we're going to take 1/2 of 107 minus 53. Once again, please show your setup on that one. Okay. And then just use your calculator to compute the answer. Should get 27 for x. All right, versus number 2, right away you see that we have 2 intersecting secants, but this one's special. We have this O is the center. So essentially this is a central angle. That's just one of our first sections we learned. The central angle is always equal to its intercepted arc. So these are 80. Leaving x to be 100. Okay. All right, number 3, we have the 1/2 of its intercepted arc. So we have this as an inscribed angle. So x is just going to be 1/2 of 93, which is 46.5 degrees. And number 4, notice the vertex is on the circle. X is an inscribed angle. So we need to find its arc and take 1/2 of it, right? So its intercepted arc will be this guy. Well, since O is the center, we know that this guy is 180 degrees. It's a semicircle. So the remainder of this arc has to be 80 degrees. Half of that, x will be 40. Okay. All right, and our last maybe challenging one, just because we have a few more variables here, we can see that we're trying to find x, but we do have an x in two different places. X is this angle out here formed by our tangent and secant. So we're going to write that equation. This angle, x, can be found by taking 1/2 the difference of the intercepted arcs. So this guy, 4x plus 5 minus 50. And we solve this equation. So you can take x equals 1/2 of 4x minus 45. You could either distribute, but I don't want to create a decimal. I'm just going to fraction bust and multiply that 2 over to this side. But either way, you'll get the same answer. 4x minus 45. And we'll get 45 equals 2x. So x is 22.5. All right. So I hope that gave you a lot of examples to look at and hopefully see those small little differences, which theorem you apply. You're either adding the intercepted arcs and multiplying by 1/2, subtracting the intercepted arcs and multiplying by 1/2, or if you have these inscribed angles, it's just 1/2 of its intercepted arc. So kind of really know those pictures, practice them. We'll review tomorrow when I get back to class. Good luck and have a great rest of your day.